Hello, this is going to be a quick, not necessarily quick, but it's going to be a good explanation of how to solve basic right angle triangles using trig. These examples come from your booklet. The first one I'm going to do is number 1E. In this right angle triangle, you can see that I've given you one acute angle on one side. The side that I've given you is the hypotenuse. And I've given you an angle. Now, in this question, I'm asking you to find all the missing parts. This question, we're missing two sides, we're missing an angle. So with respect to the angle that I gave you, this side over here is the opposite, RT, and QR is the adjacent. The opposite is the side that's across from the angle, and the hypotenuse is always the hypotenuse, it never changes. So to pick the appropriate ratio, we are going to find first the opposite side. Using our SOHCAHTOA, we are going to pick the trig ratio that has opposite, which is our unknown, and the hypotenuse, which we know, therefore we're going to use the sine ratio. And we fill it in. The sine of 48 degrees, no matter how big the triangle, is a ratio, a constant value. You can look it up on a table or use your calculator. The sine of 48 degrees in our triangle is going to be RT divided by 13.7. If you set this trig ratio up as a fraction, place the sine of 48 over a 1. To solve for the unknown RT, we are going to cross multiply and divide. So 13.7 multiplied by the sine of 48 and divide that by a 1. You're going to get an answer. Use your calculator, 13.7 rather. Multiply the sine of 48. You should be able to use your calculator all in one step. The key will be figuring out which button to hit first, 48 and then the sine, or the sine of 48. Plug that all in, you should get an answer that's less than 13.7. You're trying to find the opposite side, and the answer is 12.4 when you round the nearest tenths. To find the adjacent side, QR, you can do one of two things. Pythagoras, using the given value of 13.7 and the just recently found value of RT, or you can use trig. I would recommend trig because it's exact and it's not going to use a rounded answer for middle step. So if I'm going to find the adjacent next, and the adjacent side is the side marked adjacent, of course, QR, then that ratio with adjacent in it and hypotenuse, the given side of 13.7 is the cosine ratio. So the cosine of 48, using the adjacent side we do not know, QR, over the hypotenuse, which we do know is 13.7, that will give us QR, which is going to be 13.7 times the cosine of 48. Divided by 1, which doesn't change the answer. Use your calculator, round the nearest tenths. QR is equal to 9.2. If you want to do a check, you could, for example, take 9.2, square it, add to that 12.4, square it, and see if that equals 13.7 squared. Recognize, of course, that there was rounding for each of those numbers, so it's not going to be exact, but you will at least know if you're close. And the other thing that we're missing is we're missing the angle at T. Well, the angle at T is found by taking 180 minus the 90 minus the 48. So angle T equals 42 degrees. You could have just took 48 from 90 as well and got 42 degrees. 48 and 42 are complementary. This question was an example of using one side and an angle to find the missing parts. The second question, you're given angle 16 and you're given this time a side that's not the hypotenuse. This side here that you're given is adjacent to the angle, and the opposite side we do not know, and the hypotenuse we do not know. We can easily find angle U, but let's not do that first in case you get that wrong, and in case you use that wrong answer for the rest of the question. It's always best to use what you're given. So I'm going to circle what I want to find first. I'm going to try and find my opposite first. I'm going to label my 3.37 as my adjacent. So I go to my SOHCAHTOA and I figure out which trig ratio to use. The trig ratio that has the unknown opposite and the known adjacent of the angle 16 degrees. So we'll use the tangent ratio. The tan of 16 degrees, which is a small angle. The opposite side is going to be small compared to the hypotenuse. The opposite side, we can call it UW, or leave it as OPP, over the adjacent side, 3.37. To solve for UW, you're going to again multiply. The unknown in this question remains on the top still. So to solve for any answer that's on the top, you will always end up doing a multiplication mathematically. So UW is found by taking the tan of 16 degrees, make sure it's always in degree mode, and multiplying that decimal value by 3.37. And check your work. If you round it to the hundredths place, you'll get 0.9663 or 0.97, which is reasonable if the other side is only 3.37. It's got to be a small number. Now we're going to solve for the hypotenuse. And to solve for the hypotenuse, we are going to use the given side of 3.37, and we're going to solve using the cosine ratio, because the cosine ratio has adjacent and hypotenuse in it. The cosine of 16 degrees is found by taking the adjacent side, 3.37, and dividing it by the hypotenuse, which you could write UV or you could write it as the hypotenuse. Now to solve this ratio, where the unknown is on the bottom, you're going to have to multiply 3.37 times it by 1, which of course is 3.37, and then divide it by the cosine of 16 degrees. And the answer you get should definitely be longer than 3.37. So plug that into your calculator. You should get an answer of 3.5058 or 3.51 when you round to two places. I kept two places because the other side was given in two places, and I didn't give you any other instructions otherwise. The last thing you need to find, which is missing because you have one side already, there's your remaining sides. You have two angles, and the last angle, angle U, would be, add 4 gives you 20, 74 degrees to find the remaining angle. Example 3. This example is important because this time we are given two sides and no acute angles. Pick a place to start. I'm going to pick angle C. And once I know that I'm going to find angle C, I'm going to label my sides. 19 is the opposite of C, and 31 is, of course, the hypotenuse. So, ka, toa. To solve for the hypotenuse first, we're going to use the sine ratio. So the sine of angle C, we don't know angle C. We need the opposite side, 19, and the hypotenuse of 31. So you're going to cross multiply a divider to get 19 divided by 31, which you're going to translate into a decimal. 19 divided by 31 is going to equal 0.6129, etc. You need to change that value somehow into an angle. So anytime in a trigonometric question you're required to find an angle, you're going to have to use the second function button on your calculator. So take the second function sine, written like this, angle C is equal to sine the -1, which I don't think we're going to worry too much about that, of the decimal value. I'm okay if you skip this step and go directly down to the answer. With the calculator, angle C is going to equal 37.8 degrees if you round the nearest tenths. To find the other angle, angle A, you could cheat, and if angle C is absolutely correct, you could subtract that from 90 and get angle A. I am not going to cheat. I'm going to relabel my triangle. Angle A, if I look at my perspective of the triangle from angle A, then the 19 is now going to be considered to be the adjacent side to angle A, and the hypotenuse is the hypotenuse. So to solve for angle A, where I have the adjacent and the hypotenuse, I'm going to use the cosine ratio. And I'm going to take 19 and divide it by 31. The decimal value is the same, 0.6129. But the second function, the cosine of that value of 0.6129 is going to equal the predicted answer, which is the complement of 37.8. But use your calculator to prove it. Make sure it's in degree mode. The cosine, the second function cosine of angle A is going to be 52.2 degrees. And of course, angle A and angle C have to add to give you 90. Because the other 90, which is the right angle, completes the 180 degrees of the triangle. To find the third side of a triangle when you're given two sides straight up right from the beginning, the only way you're going to want to do that is by Pythagoras. So 19 squared plus side A squared is going to equal 31 squared. And then rearrange. So that side BC, or side A, is going to be 31 squared minus 19 squared. And then take the square root. And that answer is going to work out to be 24. Even. Well, rounded, I guess, or whatever. 24. And that's your third side. We've completed all the angles and all the sides, so that question is complete. You can do one more like this for practice. If we're trying to find an angle, pick an angle. Let's find angle K. With respect to angle K, the two sides that we're given is, first side's the opposite, The second side is the adjacent to angle K. If you start with angle J, then 75 would be the opposite and 155 would be the adjacent. The trig ratio that has opposite and adjacent in it is the tan ratio. So the tan of angle K is going to equal opposite of 155 divided by the adjacent of 75. You take your calculator and you do 155 divided by 75 and get a decimal equivalent, which is going to equal whatever it is, 1 point something something something. Take the second function tan, and that'll give you tan, second function tan of 155 over 75. And hit your angle button. Angle K is going to work out to be 64.2 degrees. And you can find angle J if you want to subtract that from 90. If you want the trig practice, we can do angle J the real way, the good way, the no cheating way. The way to find angle J without cheating would be to say that 75 would be the opposite and 155 would be the adjacent to angle J. So we could do this. The tan of J equals 75 over 155. So do the second function of 75 divided by 155, and angle J will work out to be 25.8 degrees. And of course they had to give you 90. So you know you're on the right track. If you want to solve for the hypotenuse, JK, the best way to do the hypotenuse is to use the two pieces of information that you're given. And you're given two sides, 155 squared plus 75 squared equals JK squared. And if you solve using Pythagorean theorem, you're going to end up with an answer that's longer. And when it rounds, it gives you a value of 172. The next question is number 3. It gives you facts without a diagram. So it says triangle X, Y, Z, and the 90-degree angle is at Y. So draw yourself a 90-degree triangle. Make sure the Y goes at the 90. X and Z doesn't matter where you put them, but it does matter where you put your dimensions. X, Y, which is going to be, so I didn't draw it very well with scale. Let's read the whole question first. 102. YZ is 73. And we're asked to find all missing sides and angles. So just like the question we just did, you're required to find an angle. Let's say you want to find angle Z. Well, with angle Z, you know that 73 is the adjacent side and 102 is the opposite side. So the tan of angle Z is equal to 102 divided by 73. So 102, multiply it by 1, and then divide it by 73, and that's going to give you the value for angle Z. Take the second function, tan, and you will get 54.4 degrees. Angle X is different. Different angle, different perspective. So if you're looking at an angle X, the side that's opposite was the old adjacent. This is now going to be the opposite side, and this is now the adjacent side. So to find angle x using trig only, you would say tan of angle x is going to equal the opposite side 73 over the adjacent of 102. So 73 times 1, 73 divided by 102, get a decimal equivalent, and then take the second function tan of the quotient of that 73 divided by 102, and the value for x is going to equal 35.6 degrees. And z and x, of course, should add together to give you 90. To find the third side, because you're given two sides already, and they're both legs, 102 squared plus 73 squared should equal the hypotenuse squared. So 102 squared plus 73 squared, add it up, take the square root of those numbers, will give you the hypotenuse, and the value of the hypotenuse. Do the work on your calculator, you'll get 125. They were all given in centimeters, so 125 centimeters is the correct answer. Question in your book number 4 gives you a triangle MNP, and it says angle P is 90, angle M is 62, and angle N is 28. Find all the missing sides. Well, there's a problem with this question. On purpose, I'm sure, is why it was designed. You cannot find a missing side unless you have at least one side. You can't use trig because you don't have any sides at all to use. This is an impossible question. The missing sides are unknown. So leave it as it is, and all you can represent in this answer are the three angles. Cannot use trig without at least one side. Tricky question. The next one, number 9, is a word question, but they've also given you the diagram below. The straight support wire of a telephone pole makes an angle of 62 degrees with the ground. That's a key, with the ground. Notice the wire and the ground. Angle between them is 62 degrees. The wire is fastened to the ground 5 meters from the bottom of the pole, I guess. Can't see what that says. Determine the length of the wire and the height of the telephone pole. We want to find the height of the pole and the length of the wire. So we're going to start off first by recognizing we have angle 62, and the 5 meters is the adjacent. So we have to find x, we've got to find y. If you start by finding x, x is the opposite, and 5 is the adjacent. So we would use a trig ratio of tangent to solve for the height. The tan of 62 degrees is going to equal the height x over the adjacent 5. And to solve for x, where the unknown on the top, you're going to multiply. So take your 5, multiply it by the tan of 62, and that's going to give you an answer of 9.40, unrounded. That's in meters. If the question doesn't tell you how to round, you can go with what's similar to the question. I always go with tenths if in doubt. To find the length of the support wire, that's y. And with respect to the 62 degrees, the y is the hypotenuse. So you're going to use a ratio with adjacent and the hypotenuse in it, you're going to pick the cosine ratio. So the cosine of 62, because it has adjacent in it, is going to equal the adjacent side of 5 over the unknown hypotenuse. Call it y, you call it whatever. In this example, the unknown is on the bottom. You're going to have to actually divide. To do this, it's written as the hypotenuse is found by taking 5, multiplying it by 1, which is 5, and dividing it by the cosine of 62 degrees. So 5 divided by the cos of 62 works out to be 10.65 or 10.7 meters if you round. So it's all about choosing the proper ratio, making sure the proper side on the top and the bottom of your fraction. If your unknown's on the top, like it was in the first example, you're going to end up multiplying the bottom by the tangent or its cosine or sine value. If your unknown's on the bottom, you're going to end up dividing by your sine, cos, or tangent value into the number on the top. And the hypotenuse is always a bigger number. Question 10. How high is the kite above the ground when the string makes a 63-degree angle with the ground? Again, terminology with the ground. That means the angle goes between the string and the ground. Your hands are 1.7 meters above the ground. So this height is relevant to the question, but it's not part of the triangle. So it's an after calculation, not an immediate calculation. How high is the kite above the ground? That's the opposite side. So if you're given a question where your unknown is the opposite and your given is the adjacent, that's a tangent question. It must be solved accordingly. So the tangent of 63 degrees is found by taking the opposite side, call it x or OPP, divided by the 12, which is the adjacent side. So to solve for x, you would do 12 times the tan of 63. Again, make sure you're in degree mode on your calculator. The tan of 63. And your answer for x should be greater than 12. And the answer for x is going to be, proper rounding, 23.5513. That's the height of the string from the hands up. But you have to consider that you were given also the height of the hands. So you add 1.7 to that number and do your rounding at the very end always. And you would get 25.3 meters for your final height of the kite. Last question that we'll do together. A 25-foot ladder, classic question, leans against a building. So a ladder up against a building. The assumption is the building is generally perpendicular to the ground. So therefore, when you lean something up against it, it's probably on level ground. The foot of the ladder is 4 meters from the edge of the building, or 4 feet rather. And a 25-foot ladder, so my ladder is very, very badly scaled. It should be much steeper and much more dangerous. I've got it almost like a 45 degree, but it wouldn't be. What angle to the 10th of a degree does the ladder make with the building? This is a very important wording. Angle does a ladder make with the building? Well, the ladder is here, and the building is the vertical. So the angle is the angle made inside. That's your unknown angle. We'll call that theta. With respect to that angle, the 4 feet is the opposite and the 25 is the hypotenuse. So you would use one of your 3 trig ratios. The one that has opposite and hypotenuse is the sine ratio. So the sine of the unknown angle theta, or any letter A or whatever, B, C, doesn't matter, is going to equal the opposite of 4 divided by the hypotenuse of 25. So to solve for the angle, remember it's always a second function. You do 4 divided by 25 and then get your second function of that. Second function of that value works out to be 9.2068 degrees. So the angle is going to be approximately 9.2 degrees. That's the angle that it makes with the building, which is up there, a very small angle here, a very small angle. And a very big angle, which actually should have been drawn more like this. Very steep. And that's trig in a nutshell. Basic trig, that is. We'll revisit next time.